second derivative test, and this is the tail end of your homework. And so first of all, the second derivative test, okay, actually states let f be a function such that the first derivative equals 0 and the second derivative of f exists on an open interval containing c. If the second derivative at c is greater than 0, then f has a relative minimum. So when we talk about something being greater than 0, what type of number is it?
A positive.
A positive. So see, this is kind of a little bit opposite. When you have a positive second derivative, that implies that you have a relative minimum. Okay, now in the next one, if the second derivative is less than 0 or if it's negative, then f has a relative maximum. So it's kind of one of those things that is opposite. So when you have a positive second derivative, you're going to have a minimum. When you have a negative second derivative, you're going to have a maximum. If the second derivative equals 0, the test fails. Now, the test does not always work. That's the thing. That's why we're going to spend a little bit of time, but we're not going to spend an entire amount of time on this. Okay? If the second derivative equals 0, the test fails. And then what you have to do is go back and actually go through the first derivative test, which is what we did when we did increasing and decreasing stuff. Okay? So let's go ahead and look at an example. All right, find the relative extrema for f of x equals negative 3x to the fifth plus 5x cubed.
Oh, you know when to use the second derivative test.
It'll say, and in your homework it does say use the second derivative test. So what I'm going to do first of all is I'm going to find my critical numbers. So I need to find my first derivative.
Negative 15x to the 4 plus 15x.
Okay. So find my critical numbers. I set the first derivative equal to 0. So what do I get?
15 outside.
Let's take a negative 15. Okay. Minus 1. So really, where do my critical numbers occur?
0 plus or minus 1.
0 and plus or minus 1. Okay, remember when you have that x squared, you're going to have both values. Okay, just like your quiz. All right, so then now what we're going to do is I'm going to find the second derivative, and I'm going to plug these values in. So the second derivative. Okay. Second derivative will be what, folks?
Negative 60
Yep.
x plus 30x.
Okay. So now what I'm going to do is I'm going to take each of those values, 0, plus, and minus 1, and I'm going to plug those in and I'm going to find out what they are. So first of all, let's plug in 0. And I get what? 0. So that tells me that the test fails. Yeah, stinks. So now what I'm going to do is I'm going to plug in positive 1. If I plug in positive 1, what do I get? Negative 30. So that tells me I have a max. Because remember, it was the opposite. All right, next one. F double prime of negative 1. Positive 30. So that tells me I have a min. So therefore, you can conclude that you have a minimum at negative 1 something. So you have a min at negative 1 something that you need to find. And then you also have a max at 1 something. So now how do I find that something? Plug it in. Yep, plug it into the original equation. And so what do I get? Max at 1 what? Not too hard. What? 2.
Well, what?
Okay?
Flip.
min at -1, which is going to be negative on both of those. So the min will be at -1, -2.
Oh, I was putting 30 in the original, you just put
No, just plug the x values in. Okay.
that.
Now-
How the heck did you guys get that so fast?
We need to figure out what happens at 0, 0. So to figure out what happens at 0, 0, we need to look to the left and to the right. And so we have to use our first derivative test. Okay? So if I go ahead and plug in -1, so I'm going to look at -1 and +1 here. If I plug -1 in here to the first derivative, I'm going to get a negative times a what? Well, actually, I can't plug -1 because I'm going to get 0. I'm going to have to plug in 1/2.
Wait, why are you putting?
Because I'm seeing right now if it increases or decreases to see if it's got a min or a max. Okay?
At 0, 0.
So-
At 0, 0.
Because when the test fails, that's what you need to do. Okay? So what we're going to do is we're going to look to the left of that point and to the right of that point, and we're going to see what it does on either side. So if I plug in -1/2 here,
Get negative and negative.
I get a negative and a negative, which is a positive. So that means the graph increases, right? Okay, so let's plug in +1/2, and what do you get? +1/2, +1/2, what do you get? Negative and a negative, which is a positive. So the graph increases. So this is the thing. If the graph increases both to the left of that 0, 0 and to the right of that 0, 0, am I going to have a min or a max? No. And in fact, if you look at the graph, you're going to see that at this point, 0, 0, what it actually does is it does this. The graph does something like that.
So where's the min and max at?
The min and the max are right here. Well, it looks like this. And this is 0, 0. Okay, and so that's why the test fails, and so there's nothing at 0, 0. So what you're going to do is you'll pick a value right to the left of that and right to the right, and then you'll just do a quick first derivative test. Okay? So that's the second derivative test in a nutshell. You should be able to do those 5 or 6 problems now. Okay, that was the 27 through 32 in section 3-4. And that's pretty much it for today. So quiz time.